What is the usage of the data frame? If you observe in the RDD, RDD is not best fit for structured data, right? I mean, you can read any type of data from that RDD, but the RDD especially, I mean, you can read the data from the unstructured data, right? The data could be, I mean, for example, the data could be anything, right? For example, if you're sending the, last time we have read the some EMP underscore 19234, right? But if you want to do the transformations, right, it's very hard to do the transformations, right? It's very hard to do a transformation. It's very hard to eliminate the, especially your header information. If you want to read the data from that multiple files, for example, I'm reading the data from the 5 files, right? 5 files, but each and every file is having the header information. To eliminate the header also, again I need to add the n number of transformations, like filter transformation I have to add, then I have to eliminate on top of it, I mean, I have to eliminate the header information. Because if you want to include the header information, again I have to include the transformation, right? On top of it, again I have to execute the distinct, then the data plus header explicitly have to combined, right? Only for simple reading the data from multiple files only, we are doing the two-minute transformations, right? So that is a basic, right? Especially reading the data from the multiple, reading the data from the files, there is a basic operation for any data engineer and any ETL developer, right? The same operations we were executed in ADF with copy activity. The simple, I mean, we check that box, skip that header, right? But if you are reading the multiple files, all that headers will, it will exclude, but only one header will be available, right, from the data factory. Any ETL tool reading the data from the multiple files, there is a basic operation, right? That is basic operation. But from that already, it's very hard to implement that logic, right? But how about other transformations? Maybe I want to perform the joins. I want to do that union, right? Especially the same structured operations I want to apply. But RDD, it's not worried about the same structure. It is worried about whether it is RDD or not. If it is RDD, blindly it will do that union also, right? But that is against to your set operations, right? That is against to your set operations. But how can I perform the detailed transformations? My complete ETL flow, aggregation rules I want to apply, the sorting I want to apply, right? In detailed essay type 1, type 2, type 3. Maybe I want to read the data from the table. So these operations are not available in that RDD. So these are indirectly kind of your limitations, right? These are indirectly kind of your limitations on your RDD, especially from the structural point of view, data engineering point of view, or ETL developer point of view. So these are the complexity, right? These are the complexity. But I want to read the data from the structure. Maybe I want to read the data from the semi-structure, like your JSON data. I want to read the data from the table, maybe Azure SQL DB or Teradata or Recipe HANA. Right? I want to read the data from any delimited files. I want to apply the SCD operations, SCD type 1, type 2, type 3. Right? I want to apply the detailed filter logic, especially the column level. The column level, I want to apply the calculations. Right? Maybe the salary greater than or XYZ value. Right? I want to do the order calculations. I want to select two only specific columns. Right, out of 100, I want to select to only the specific columns. I want to create my own schema definition. I want to create my own schema definition. Right, I want to make out my process failure if I'm encountering any bad records. Right, I want to apply the my where class. I want to apply the all the joins, um, self join, maybe inner join, left outer join. Right, I want to apply all the joins. Right, I want to apply the my set operations. I want to apply the my set operation based on my common structure. Right, based on my common structure. I want to apply my regular expressions onto my specific columns. Maybe I want to call out my user defined function to perform the my data transformations. I want to implement the SC type 1, type 2, type 3. So these kind of things we cannot apply in the RDD. But where can I apply these things? Right? Any data engineering or ETL developer, 90% he will do the structured data, right? He will process only majority the structured data. The unstructured data very rare, but depends on the requirement. But 99.9% all the requirements, right? All the especially use cases requirements will deals with the maximum structured data, right? Will deals with the maximum structured data. But how can I read the data? But RDD it will not help out. That is more over low level API, right? That is low level API. But yes, we should think about the structured APIs, right? We should think about the structured APIs. I want to read the data from CSV file. I want to read the data from the table. The data is in the proper structured manner. But how can I read? How can I read? The, yes, we'll use the DataFrame API. With the help of the DataFrame API, you can read the structured data or semi-structured data. You can read the data or semi-structured data. Means your data is look like in the spreadsheet format, right? I mean Excel, right? Spreadsheet nothing but Excel, right? Database table, right? Database tables. Your Excel and spreadsheet database tables always will define the predefined structure, right? Predefined structure means you will define the column names, right? Right, you will define that column, especially in the table, right? Especially in the table, if I want to create any table, if I want to create any table without structure, it's not possible to load the data, right? The step one will do the create definition, then only will perform the DML operations. Otherwise, it's not possible, right? Otherwise, it is not possible to create any table. Otherwise, you can create table name as select star from table. Same here also in that example also. Step one, it will create the predefined table structure, table with structure. Then it will populate the data. It will populate the data. Right. Here also the same thing in the data frame also. The data frame also it is equivalent to your database tables or your Excel spreadsheet. Right. If I want to create any data frame, yes, I need one predefined structure. Predefined structure, then only it will take the data from your file. It will take the data from your file. Means these all the operations while creating the data frame, we should define your structure plus you should define your especially data point. You see, a data frame is the most common structured API and simply represents a table of data with rows and columns. Table nothing but a combination of rows and columns and tuples and attributes, right? The list of columns and the types in those columns, the schema. It is a predefined structure. But while creating the your data frame, it will take the first schema definition, means that is a column names plus a data types. Schema nothing but a combination of your column names plus a data types. In the simple terminology, a spreadsheet with named columns. A spreadsheet with your named columns. Means it is a predefined schema definitions. If you don't have that schema, it will create the schema definition. For example, maybe your table or your file is not table, your file is not having the structure. Means only the data, not header information. It could be possible, right? It could be possible. At that time, the Spark will create the default structure, or you can explicitly create your own structure up to your vision. But without column names, you will not see that any data frame. The step one column names is mandatory to your data frame. In case your file is not having that column names, the default the Spark will create own column names. It will create own column names. Right, that Apache Spark data frame API provides a rich set of functions, means your transformations. Like you can select specific columns. You can perform the year filter condition, like in database point of view, query class. This select columns means select ID, comma name, comma salary from table means from data frame. Filter condition like your where class. You can perform the join, right? You can perform the join between one data. I mean here the in the database point of view, if you want to perform the joins, at least two tables, right? Two tables required. Here also, if you want to perform the joins, right, between the data frame. So in the last class, we had discussed about the join between the RDDs, right? Here the join between the data frames. You can perform your aggregations like sum, average, min, maximum, count, right? String aggregate functions also you can apply. String aggregate functions also you can apply. Right? That allows you to solve common data analysis problems efficiently. you can apply your all ETL transformations, right? You can apply all your ETL transformation on your data frame, right? Either you can execute Spark SQL queries or you can execute your data frame transformations, right? So we'll talk about in detail one by one. Data frame underscore one. For step one, how to read the data from the file system. How to read the data from the file system. Let, we'll take this file. But before reading, let me check the data. Let me check the data. Yeah, ready. But how can I read the data from this customer.csv file, right? How can I read the data from the customer.csv? Okay. Spark dot, the syntax, spark dot. If you want to read the data from that any CSV file or any table, spark dot read dot, spark dot read dot format. Spark dot read dot format. Here the format could be anything. It could be JSON, it could be table, it could be Parquet, it could be CSV, could be anything. Right? What is your format? My format is that CSV. Spark dot read dot format dot CSV. I'm not using any other options. Simply I'm reading the data from that only the CSV. Spark dot read dot format dot. Here in between we'll use some other options. I'm not using that option directly. I want to import the CSV file. Import the CSV file. How can I import? How can I import? That is called your load. That is called your load. You can provide your file name. Here you can provide your file name. Spark dot read dot format of CSV dot load your file name. Dot load your file name. So with the help of this syntax, we can create the your data frame. We can create your data frame. Then you should define one object, right? You should define object df underscore read df underscore read. So this is your variable name, right? This is your identifier name, variable name, right? Yes. With the help of this syntax, we'll load the data from the CSV into df underscore read data frame. Let me go and execute. Let me execute shift enter. That here data frame has been created. Here data frame has been created. Just observe it is contained some underscore C0 underscore C1, right? Right, underscore C0 underscore C1 underscore C2. Right, underscore C0 underscore C. These three column names were created, right? Like your table only, right? Like your table, right? Like your table. These are the column names. These are the column names. It means, do we have the columns header information in our file? dbutils.fs dot head. We have the header, right? If I'm not wrong, we have that header information. We have that header information, right? So I think we don't have the header information, Kiran. I think we don't have the header information. So we don't have the header information, but the data frame we discussed, it is a predefined definition, right? If your file is not having the header, it will create the default column names underscore C0 underscore C1 underscore C2, because it is similar to your table. In the table also, without your column definition, means your schema, right? The column names plus data types equivalent to your schema, right? Column names, data type equivalent to schema. In case if your file is not having that column header information, so by default it will consider their own column names, own column names, right? If you want to see the type of this object, type of this object, right? Type of this object, it is equivalent to PySpark dot SQL dot DataFrame dot DataFrame, right? This is your API, right? This is your API, means this is your data frame. Now df underscore RDD is equivalent to your data frame. This data frame is having the data, right? I mean, this data frame is loaded with the data from the customer.csv with the help of the spark.read.format with the help of the CSV module. With the help of the CSV module. Let me go and create one more file. ID comma name comma salary 101 5000 102 B 2000 103 C 4000. The next example also, let me create another file. Let me create another file. Let me create one more data frame. Right, def underscore read emp. Okay, let me go and execute. Right, again still it's considering the underscore C0 underscore C1 underscore C2, right? But we have the data, right? We have the column header information, right? We have the column header information inside this file, right? Yes, we have that ID name salary, but why it's not considering? Why it is taking their own column names? Why it is taking their own column names? Why it is taking their own column names? Right? But how can I inform to my API? Please consider ID name salary. Don't go with your own column definitions. Don't go with your own column definition. How can I inform to my CSV module? Please consider these column names, ID name salary, right? ID name salary. Let me go and create, right, the same data frame, right, with option dot option. Especially in the data factory, that is a graphical user interface, we have selected that option, right? Because this is here you have to write your Spark SQL code, right? Or Python code, right? PySpark code you have to write, right? You have to inform to your CSV module, right? Please create the data frame with these options, with these options. That option one is called header information. Header, yes, header equivalent to true. Header equivalent to true. Header equivalent to true means my file is having the header information. My file is having the header information. Please create the header from this file. Now you're able to see ID, name, salary, right? You're able to see ID, name, salary. What is the difference between the previous example? In the previous example, right, that header equal to false. So default header equal to false. Header equal to false means PySpark it will create, or Spark or PySpark will create own column definition based on your delimiter. Here the default delimiter is a comma. Here I haven't mentioned any specific delimiter, right? If you want, you can use dot option separator comma option. You can use comma or at the rate semicolon pipe symbol. If you want, you have to include. So this is the default option header equal to false. The default separator is at comma. So right, it's creating the columns. It is creating the columns based on the comma separator, right? Based on the comma separator. But how it is deciding ID the separate column, name is separate column, salary is separate column, based on your delimiter, comma delimiter, right? While creating into the your data frame, so by default it will consider the this is interview question, right? No need to explicitly mention the your comma delimiter, right? No need to explicitly, implicitly your Python the default option the delimiter is a comma. In case if you have that additional delimiter, right? Not only comma, maybe you have the pipe symbol, right? Maybe you want to read the data from the delimiter of the pipe, then explicitly you should mention your delimiter information. Implicitly it is a comma separator. Even the schema definition also, right? Schema definition also, if you observe the Python only, right? Your PySpark only created the schema definition, right? Your PySpark only created the schema definition, column names plus data types. But if you mention header equal to information, then it is not creating their own column names, right? But column names are mandatory, right? Column names are mandatory. But it is equivalent to your table. Column names are mandatory. If you want to ignore your header information, please use header equal to. If you're not including this option, means header equal to false, then it will create their own column names underscore C0, underscore C1, underscore C2 based on your default comma delimiter. Clear, right? Okay. So what is the next command? What is the next command? Right. No, I don't want to see the schema definition here. Do we have the any specific command? Do we have that any specific transformations or functions? It should display schema definition. Schema definition. Right. Then we'll use that one more transformation. We'll use the one more transformation. Print, print schema. Right. Let me go and execute. All right. Now you're able to see the root ID name salary, right? If you want to display the especially the schema information, right, we'll use the specific function print schema function. We'll use the print schema function. But if you want to see the schema definition on your data frame, whether your schema is having the proper column information or not, see nullable equal to true means you can allow the null value. You can allow the null value. But this column is null constant, right? Null constant means you can allow null values to these columns from your CSV files. From your CSV files. From your CSV files. Right. So what is that other easy way? Right? What is that other easy way to see the schema definition? Right? Schema definition. Either print schema or you can use df underscore read sorry df underscore read underscore emp dot schema. Right. Here it will give the complete your information. See, so this is very very important. Struct type struct we will discuss in detail. From the scheme also we can extract your detailed definition of your data frame. detailed definition of your data frame, but it will talk about some structure type, structure field information. See, the first column is ID, the second column is your data type, the third column is true, right? Nullable. If it is false means, right, you will not allow the null value to your salary column, ID column, name column. We can explicitly create this definition also. We can explicitly create this definitions. It is a combination of your structure type, structure field. If you want to see the struct definition, we'll use the schema. If you want to see the normal schema, column names, data types information, we'll use the print schema. We'll use the print schema. Then you have the doubt, right? Why all the data types are belongs to string data type? Alright. Why all the data types are belongs to string data type? But we have the data integer string also, right? We have that integer data, number data, and text data. But why all the data types are belongs to string? In all your data frame definition, the data types are belongs to string only, right? The data type definitions are belongs to string. How can I create my own data types? Why default it is considering the string data type, right? Why all these columns are marked to string data types, string string data types, right? But which option we should use, right? Which option we should use? Let me go and create the same data frame, right? We have that one more option, info schema, info schema equal to true. Let me expand. Now you're able to see that integer, right? Now you're able to see the integer. But in the previous example, right? In the previous example, right? All the data types are belongs to the string data type, right? All the data types are belongs to the string data type. But here, all the data types are belongs to string data type. Right? Here we are seeing the proper header information, but the data types, right? The schema, right? The schema information, right? The data types information, right? Everything is belongs to string data type, right? All the columns data types are belongs to string data type. But here you're able to see based on your data, it is creating the data types, right? Right. I want to inform to my CSV module, please create the data types based on your data. But how can I inform to my CSV module? Then we'll use the infer schema equal to this is 100% interview question. Infer schema default it is false. Default it is false. If you're not mentioning inferential schema true, right? By default, Python will create all the data types to string data types. Your data type, your schema definition, right? All columns are equivalent to string data type. In case if you mention infer schema equal to true, right? Then your CISV module or PySpark engine, it will check each and every column data. Right? This column data contains which data type, which data, whether it is integer, whether it is a decimal data, whether it is a string data, right? Whether it is float data, each and every data point it will check, then it will assign the right data type. It will assign the right type. But if you're taking that inferential schema equal true, right? Definitely it is a performance issue, right? It is a performance issue because each and every row of the column it should check, then it will provide the right data type information, right? Right data type informations. Bus inference schema false means so by default it will give that all the data types belongs to your string data type. So it depends on your requirement. In your requirement, right, data types are mandatory. Means integer or string is mandatory. Right, you're performing the calculations. Maybe you're performing the validations. Right, it's mandatory to define the data types. Right, then we'll use that inferential schema equivalent to true. Inferential schema equal to, but you will see that performance issues. At least 10% or 5 to 10% you will see the performance issues compared to that inferential schema false. Inferential schema equal to false. Clear, right? Now let me see the print schema and schema definition. ID name salary. ID name salary. Integer, string, integer. See, integer type, right? It is integer type. It is a string type. This is integer type. The previous example, the three are string type, right? String data type, right? String. Inferential schema equivalent to true means it will create the data type based on your data. So by default, inferential schema equal to false. If you're not defined inferential schema, right, then Python, right, your PySpark will consider that is equivalent to false. It will create, right, all the columns of data types set to string data types. If you're setting inferential schema, if you're explicitly mentioned infer schema option, right, infer schema option equal to true means based on your data, your PySpark will decide the data types. Any doubts? That header and infer schema. Clear, right? Header equal true means it will skip that header. Infer schema means it will set the data types. Only in the simple terminology, it will include the header. It will set the data types based on the data. Based on the data. So the next, clear, right? What is the usage of print schema option? Print schema, it will display the DDL definition of your data frame. Right? See, this is because the commands are case sensitive. S capital, right? S capital here. If you observe infer schema also, S capital. Infer schema also, S is a capital because the commands are case sensitive. The commands are case sensitive. Right. If I want to see the data, if I want to see the data, df underscore read dot emb, how can I see the data? There is a show option. There is a show option. If I want to read the data, right, if I want to read the data, that will use the show. Right. Will see the show data. Right. Df underscore read emp dot show option. You will see the data from your data frame. Otherwise, you can use the display option also. You can use the display option also. Df underscore read underscore emp. The display is a more readable format, like it is a tabular format. If you're using the display option, that already we discussed, red display. It is a tabular format. Still, if you want, you can display you can download that output. If you want, you can perform some kind of your charts also. If you want, you can perform your charts. All right. If you want, you can do some self visualization also. All right. You can do some self visualization. Right. If you want, you can download the data maybe during your development or maybe during your code fix or bug fix, right, in the production, right? You want to see the data, right? You want to see the data, right? That maybe you want to see the data into the Excel, right? You want to see the data into the Excel, then you can download the CSV, then you can open the data into the Excel, then you can do that validation. Maybe if you want to share this data, right? You want to share the data to your users, then you can manually execute a display option, download the data, and you can share to your users. If you want to see the data, we'll use either show option or display option. Show option or display option. All right. If you want to see the count, all right. If you want to see the count, all right, we'll use the count function, the same RDD, right? In the RDD also we have the count function, right? We'll use the count function, df underscore read underscore emp dot count function. Df underscore read underscore emp dot count, right? It will display the your number of records. It will display the number of records from your data frame. From your data frame. If you want, you can assign to the one variable, right? You can assign to that one variable because this is the integer, right? It is an integer. You can assign to their own variable. You can capture the data into that variable also. Correct. So these comments will not use in your main command, right? Especially display, show these comments you will not use in your main code, right? Just only during your development, during your testing, right? You will use these commands and you will execute, you will see the data. But in your final code, the show and display, the print schema, right? The print schema definitions you will not use, right? You will not use, right? The schema yes will include, but these things you will not include. This is your testing purpose, and during your development you want to see the what kind of data types are available, right? At that time you will check, right? You will check. Even the show option display during in your main code you will not include. Maybe your test code, your development code you will include. In your main code you will eliminate these commands, right? The count yes will include, because see here that output, right? That output is integer. Maybe you will include, this is in your main code. Maybe you want to perform some, you want to add this information into your log table, right? At that time this count will help out, right? This count will help out. Clear, right? The data frame dot count, right? Count the number of rows from your data frame, from your data frame. If you want to collect the data, right? You want to collect the data, right? You want to collect the data, right? We'll use the collect function. It will collect the data from your data frame, right? From your data frame, right? It will give the list, right? Already we discussed in the RDD, right? Right. It will give the your list. It will give the your list. It will give the your list information. The collect function will use it to collect the data from your data frame, right? Collect the data from your data frame, and it will save that output into the list format. Save that output into the list format. But already we discussed, right? So now see, this is ID equal to 101, name equal to A, salary equal to 5,000, ID equal to 102, name equal to B, salary equal to 2,000, salary equal to 4,000, name and ID, right? If you want, but don't execute collect function on your main data file, right? Because unnecessarily it will load the huge amount of data into your driver program. Don't use collector. Yes, you have that minimal data like your schema information, some column names information, hardly 10-15 records, right? 10-15 records, maybe column definition, not your business data. Then you can use with, yes, you have the requirement to see the data, right? See the data on top of it, you want to perform the calculation, then you can use the collect. But on your business data, nobody will do the collect operations, right? Or you want to do any looping on your business data. If your business data contain 1 million record, 1 million records, nobody will apply the looping concept, right? The loop should be hardly maybe 100 records or 200 records, right? In that, if you want, you can iterate. Yes, you can do that iterate. But 1 million record to 20 million record to 1 GB data, you will not do that looping, right? Yes, you can execute the collect function on data frame, but you should think about your data should be very minimal. If your data is having the huge amount of data, your driver will load with overflow issues, right? Your driver loads with overflow issues. Always, we should not load a huge amount of data to your driver program. Clear, right?
Can we do a slicing on that from the collection?
Means slide thing means I did not get you. What?
I mean, I want to take only first row or
We
second row.
can. We have the option, right?
Mm.
Df underscore read underscore emp dot.
Okay. Same RDD functions.
Same functions.
I mean, we can see that which node uh, uh, um, also in the data, which data is in which node.
Mm. We can, we can check from. I mean, those things are the backend operations. Right? We can check from the, especially your cluster. df underscore collect, right? You want to
Yes, yes.
collect. I mean, we should create one more already, one more data frame, right? We are creating that one more data frame, right? Because first also it is a your action, right? Because we
Yes.
don't have the right. Again, you have to create one more data frame. From the data frame, you have to use the collect function. What are the, sorry, this is not data frame, right? This is your list, right? Yeah, this is your list, right? Only you can see that first one. Yeah, right. First is not a data frame, right? Because we are executing on the list against the collect function. It's not possible, right? But the same RDD transformation also we can implement here. The RDD transformations we can implement here. Okay, the next one, I want to read the data from that multiple files, right? I want to read the data from that multiple files.
But if data is more, we should not use collect, right?
Sorry,
If data is more, we should not use collect.
mandatory step, don't execute any collect function. Only use that collect function, right? You're taking some schema column names. You're taking some number of files, right? For example, in this requirement, okay, I will explain it. For example, you're creating one lookup file, right? The lookup file will talk about your file name and file path information. File name and file path. So this is not your business data, right? Right, Kiran?
Yes.
Just it is talking about your file name and file path information. Maximum, you will include 10 files, 15 files, 100 files, right? So what is your requirement? I want to read the data from this file, from this file content. I want to read the data from this file path. Then I want to write the data to my target system. 100 files, right? 100 files. What is the best solutions? Let me create these 100 file names, path details into one lookup file, right? One lookup file. Let me read this lookup file from the data frame. On top of it, I will execute my looping concept. If you want to execute the looping concept, I need one lister, right? Iterator, right?
Yes.
At that time, you can use the collect function.
Okay.
You can use the collect function at that time because it will read the all the 100 files or 50 files information. Then you can put the loop inside the loop. You can create your data frame, right? Your business data, for example, your product information. Don't execute collect. Your product information contains a million records, right? What is the usage of the collect function, right? Are you performing any transformation on your product data? But if you're executing the collector, it will display the data into that list. So what is the usage of that list, right? What kind of operations you're performing on your list? Or if you have the use case, yes, I want to perform some use cases from the list, then you can implement that collect function. But 1 million records, nobody will implement the, especially the list, right? What is the usage of the, I mean, list creation here from the collect? Yes, this is the requirement, right? This is the meaningful requirement that I don't want to create, right? I don't want to create multiple data frames. I want to create only one data frame at that time. This lookup file will help out. Clear, right, Kiran?
Yeah, got it.
Hello.
One more question. One more question. Bro. So it's clear now. So one more question is like we have defined directly at DF, right? So DF
Okay.
equal to for like we use spark.read dot format, right?
Correct.
So that is the definition of data frame, right? The way
Correct.
of
That is,
define.
yes, that
Is
is
there
correct.
any is there any other way to define the data frame?
Yeah, there are many ways. The same like RDD, how we are creating Spark also, we can create with the help of the create data frame. So this is from your CSV module, right? This is from your CSV module. Now your requirement, I don't have the data from the CSV. Maybe I want to create some dummy data, but I don't have the CSV, right? At that time, we'll use the create data frame module, the create data frame API.
No, bro. One interviewer asked me one question,
Correct. I mean,
like
maybe
how to define data frame. I told like we can take spark dot read dot
right.
format.
This
He's telling that
no,
don't
no.
use these commands,
Okay,
just
I will
define
explain.
data frame.
I will explain you. So this is your inputting the data, but how you are creating the RDD? There are three ways, right?
Yes, three
If you
ways,
have the
right?
text file, you're using the text file. If you don't have the text file, then you're using the parallelize method, right?
Yes.
Right? Here also we have the same. In case I want to create the data frame, we have the data frame function. We have the data frame function. Spark dot create a data frame. Create data frame. So this data frame, it is asking the two parameters. The first parameter is your data. The second parameter is your schema definition. Schema definition. Yes, my data is not available in text file. I want to create my own data, right? I want to create my own data, right? My data is available in the list collections, right? Now your data is available in the list. Then I will take the list. I will take the list. L. Next, your schema information. Next, your schema information. Right. df dot show option. ID name A1 or 2B. That 101 A1 or 2B. So this is also one of the methodology to create your data frame. Okay. The first methodology is to read the data from the CSV, right? To
Yes.
read the data from the CSV, we have to use this option. Right? This create data frame, you don't have the data. You have to create your own data. You have to create your own data. If the data is available in the list, the data is available in the list, then you have to create the data frame. Clear, right?
Yes, yes, bro. Thanks.
So this is with the help of the data frame function. So this is will frequently use in the real time if you want to create one empty data frame, and we will discuss in detail. Okay. The step one is a mandatory for to read the data from the CSV. Alright. This is a reading the data from the CSV. Reading the data from the CSV. The next requirement, I want to read the data from the multiple files. I want to read the data from the multiple files. Now we have read the data from that only one CSV file, right? Only one CSV file. But I want to read the data from multiple CSV. This is 100% interview question. Okay. I mean, forget about interview question. 100% will use it in the real time because we'll create some empty RDDs, right? In the especially in the real time. So what is the next requirement? The next requirement, no, I want to read the data from the multiple files. Multiple files. All right. I want to read the data from multiple files. right? I want to read the data from the multiple files, right? Maybe, all right. So this is the 202104, all right? 202104. All April files I want to read. Then you can do the start.csv. You can use the start.csv. If you want to read the data from the multiple files, you can use the here wildcard character. You can use the here wildcard character. Right. Let me see the parent schema definition. ID, name, salary. Let me see the count information. Count equal to 6 records, right? Count equal to 6 records. Let me see the your data. At 101, 102, 103, 104, 105. So there is no column names are repeated more than once, right? Because here considering header equal to true, right? From these kind of things we can't execute in the RDD, right? But here in for schema to each and every file it will skip the sorry header equal to, right? Each and every row it will skip the header information, but only one header it will consider. All right, if you're reading 10 files, right, from the 10 files it will consider only one header. The 9 headers it will be skipped, right? It will be ignored. In for schema, based on your data it will decide the data types. Based on your data it will be decide the your data types. Any doubts?
Infer schema always it will be false, sir. Default.
Sorry.
Infer schema will be default false,
Yeah,
sir.
infer schema header, for example, if you're not using any, there are many options. If you're not using those options, by default, those options are false. There are many options are available. If you're not using any option, by default, it is false.
Okay, sir. But when we call an option, then we have to specify the value to it, true to that.
Correct. Yes, few options are having true, false. Few options are having their values.
Like, sir,
Clear, right?
for example, yes, sir. Like, sir, for example, we have 5 files, sir. Out of that 5 files, unfortunately, one of the file had additional column popped out while they were sending to us. At that point of time, when we put header is equal to true, right? If that is a 5th file, it will not consider it header value. Correct, sir? But
Really,
data value will come in and append into that file, right, sir?
I did not hear your question. What is you're having some header additional column, right?
Yes, sir. Now, till today, our source system was sending only 3 columns, sir. Unfortunately, there was some upgrade which happened at source system. They plan to send additional column now. So that is like one file came with additional column value. Yes, sir. Now, in this case, it will ignore that additional column, right, sir?
We'll see. I think it will consider 4 columns. We'll see. Because we are not using the permissive mode, so we'll see. We just start right. Yeah. Get like your ADF only, right?
Okay, sir.
Default. But there is an option. If you want, you can explicitly read the schema. If you want, you can explicitly schema. Because here I'm using this, right? Just target all the files it will do in for schema, right? Equal true. Then it will check, right, which file is having that more columns, right? Which file is having that more columns. So in this way, you're not making any failures. You're not making any failures. But ideal, this is the wrong, right? right? Ideal, this is wrong. I mean, few use cases this is right, but especially the standards wise, this is not the valid, right? This is standards wise. Not, they should inform to you, right? Your upstream systems are modifying the some scheme because your downstream systems, right? They are uploading the data, right? They're uploading the data. If while uploading the data or while doing the any modifications on the schema definition, they should inform, right? Always we should inline with our upstream systems, right? They should do the some impact analysis, right? If they are doing the some schema definition, they're adding the some additional columns, then they should inform that,
Yes,
right?
sir.
Because all that is called your impact analysis, right? Without informing you, right? Without informing you, if you're bringing this data, for example, if you're writing the data to some named table means they are using star, for example, table information, insert into table, select a star from this data frame. Definitely their process will fail, right? Will you agree? Now your data frame contains how many columns? Four columns. For example, just assume the same data frame, maybe you're writing into one table, insert into your table, select star from your data frame, just assume maybe, right? Now your data frame contains how many columns? Your table yesterday, right? Till yesterday, it contains only three columns, right? Your data frame contains how many columns now?
Yes, sir.
Your process will fail, right?
Yes, sir.
Maybe your downstream system, right? Your downstream system, your upstream system, they added four columns. You were not able to see that any issues because you're writing the data to ADLS files, right? You're writing the data to ADLS file system, right? You're not seeing that any issues. Okay. But how about your downstream systems? Your downstream systems, again, they are reading the data from your output file. They're writing into one table system. They're writing the data into one table. Definitely for their process will fail, right? Right? Because blindly they're using the star. Blindly they're using the star because they have the very confident on your data, right? No, we'll go with the star characters because I don't want to mention the column name list. But the best practice always we should mention the column name list. But why should I mention the column name list? Anyway, my table, your data frame, both are inline. Then why should I mention the column list? Let me go with the star because my there are this data frame contain 100 column names. So why should I mention the 100 column names? Let me go with the only star. But your process will fail, right? If you want to avoid your process, always we should use the named column list. Then you can ignore this fourth column, right, in your insertion, right, in your insertion. If you're not doing that any named column list, then definitely your process will fail. If your downstream system process will fail, they will escalate on you only, right? Why you have added this fourth column? Then you will do that some kind of in detailed RCA. Why this fourth column came into that picture, right? They will perform the detailed checks, right? Okay, till 22nd or till 23rd, we were able to see that only three columns from 24th onwards. So there is an additional column into this file. Then you'll go and check in your source files. Then you will check with the source team. Again, you will escalate to your source team, right? Because that is not your mistake, right? That is not your mistake because they were not informed to you, right? They were not. If they informed to you, you will include this column into that file. The same time, you will inform to your downstream systems because from the downstream systems, from the downstream systems, right? From the downstream systems, they will include the DDL definition changes. They will add. They will perform the alter statement, right? They will add that additional column to this table. If they're adding additional columns, then the process it will not fail, right? Clear, right?
Yes, sir.
Okay. So what is the next? Okay, my data is available in the data frame. My data is available in the data frame. No, I don't want to perform this data frame commands, right? I don't want to perform the data frame functions. What is the best way, right? What is the best way? Right? What is the best way to execute my Spark SQL commands? Right? If you want to create one temporary view, if you want to create on temporary view on your data frame, right? On your data frame, we have to use the create or replace temp view. Create or replace temp view. Right? You're creating one temporary view in your cluster, right? In your cluster, this view is available, right? This view is available if your session is active. If your session is inactive, means your cluster shut down, this view automatically it will be disappeared from the cluster memory. Data frame dot create or replace temp view, right? In the double quotes, you have to give the here view name emp underscore jv. Let me execute. Let me exit. Now view created. Now view created. Now you're good at SQL, right? Then you can use the percentage SQL option. Select star from emp underscore jv. Now you're able to see the data, right? If you want, you can perform the filter condition, right? Percentage star from 10, 20, 30. If you want, you can do that any kind of calculations. Like you can execute your SQL queries, right? You can execute your SQL queries. Right? If you want, you can perform the right. You can do the your SQL queries. You can do that your SQL queries. But the step one, we should create the data frame. Correct the step because your data is available in the CSV file, right? Your data is available in the CSV file. You want to execute the Spark SQL operation. In between, you have to create the data frame. Once the data frame created, right, on top of it execute here create or replace temporary view. Create or replace temporary view. Means it will create one temporary view within the cluster. Alright. Now the data is available into the emp underscore java. You can execute your SQL operation. You can execute your SQL operation. You can execute your SQL operation.
Sumant bro,
Here,
one question.
yeah,
Suppose we are loading one file only today, but it don't have any headers. So if you use the infer schema true, so will it take first record as header?
correct.
Okay. So but we lost the one record, right?
But
If it is
that is,
take as head.
I mean, you should know that your file definition, right? How your Spark knows whether you're sending header or not,
Okay.
right?
So in that situation, how can we manage?
That there is no way, right? You're right. Because in any technology, how your technology will decide whether you're sending the header or not, right? Yes. We have that option schema information, but that is explicitly you have to define that definition. We'll try that option. I will explain you. There is we have that one more option, the dot schema. It will give the good performance. Then infer schema true or false. But if you're going with infer schema true or false, right? You should 100% you should sure here you're sending the header or not. Header or not. But that is your agreement between your source team and your data engineering team, right? Before take up that any project, you should ask these questions, right? Are you sending that header information or not? So that is not manual upload, right? If it is manual upload, you should, educate to your end users. Always please include the header. If it is an automation tool, some process, right? Maybe some Oracle ERP system, some SAP ERP system, the writing the data into the CSV file, right? So that is a one-time activity, right? They should set up the header. If there's they confirmed we are not setting up the header, right? Don't include infer schema option, all right? Sorry, header equal to true option don't include, right? The data types we can handle, the header information there is no way to handle. There is no way to handle. Then only you can do, right? Preview the data, right? Preview the data, right? See the schema definition. Your schema contains underscore C0 underscore C1 means you don't have that header, right? You don't have that header. Then you can create one more dummy file. Then you can add your header information, right? Clear, right? The
Yes.
same last time what we discussed, right? I mean, read the data, read the data, check your data whether schema is available or not. If the schema is not available, create schema, create schema, then take the data, take the list and append, then recreate one more data frame. At that time, use the header equal to true option. But that is a lengthy process. Again, the lengthy process, right? Again, it is a lengthy process. Because only we have that option header equal true or false, right? Header equal true or false. So that is a lengthy process. You should check your data frame. The data frame contains the data collect option, right? I mean the schema definition dot schema. It will display the struct field struct type, right? It contains underscore C0 underscore C1, right? Then it is equivalent to your head. It is equivalent to your header equal to false option. Header equal to false option, right? Then go and define one more the schema definition and create a data frame, right? Create a data frame. Any doubts?
Like we can define schema before, like we know the schema definition. We can manually define that, right? In that
I
case,
mean, you're talking infer schema or you're talking about a header?
suppose if we are not using any infer schema, so is
Yes, we
there
can
any
define.
other way to?
We can define our own schema. But in the real time, yes, 90% will define our own schema. Because
Okay.
in this requirement, you should 100% sure about your schema. But always I'm expecting integer, always I'm expecting string data, always I'm expecting data type, decimal data type, right? Then we should define with our own schema. It will be the good performance because I don't want to hand over, especially this work to the Spark, right? I want to do the pre-definition. This is 100% I'm expecting only these data types. But if you're not getting those data types, your process will fail,
Okay.
right? Yeah.
Yes.
Process. Clear, right? Any doubts?
No. Clear.
So here you can execute your all Spark SQL related queries from your data frame. Once the data is available, right, you can execute your all SQL queries. If you have the two files you can read, two data frames you can read, two temporary tables you can read, then you can perform your jobs in the Spark SQL pointer. Any doubts? Okay. We'll take some duplicates. We'll take some duplicates. Okay. Let me upload the same data. me remove the DNO file. Each file have the DNO. Details. I didn't. See, because there is a refresh happened, right? There is a refresh happened on your table. But again, we should re-execute this command. Now ID name salary. ID name salary. Alright. Let me use df underscore. Okay. df underscore emp, right? df underscore read df underscore read emp. Let me order the data. 101, 101, 102, 102, 103, 103. So there are duplicates, right? There are duplicates. But I don't want to see the duplicates. I don't want to see the duplicates. I want to eliminate the duplicates. I want to eliminate the duplicates. But how can I eliminate the duplicates? How can I eliminate the duplicates from the data frame? Right? From the data frame. Then we'll use the drop duplicates option. Drop duplicates. Drop duplicates. See only the 6 records. See only the 6 records. Right? Let me execute removing the drop duplicates. 12 records, right? 12 records you are able to see because it is having the duplicates, right? 101, 102. Here you don't have that any duplicate records. With the help of the drop duplicates, we can eliminate your duplicate records. We can eliminate your duplicates. Even while reading the data from your CSV also, we can use drop duplicates. Let me create new data frame. Unique records. Unique records. Dot drop duplicates. You're able to see the 6 records. You're able to see the 6 records. You can use the drop duplicates option to eliminate the duplicates. Now, for example, I don't want to see these 3 columns. Just as I don't want to see these 3 columns. I don't want to see these 3 columns. I want to select only the specific columns. Then we can use the select method. We can use the select method. Then you can mention your column names ID comma salary. ID and salary you can mention. ID and salary you can mention. The same dot selector while creating it a data frame also you can include up to your wish or post completion of your data frame, right? For example, this data frame has been created. This data frame has been created. I want to create a DF select columns, right? Select columns. Now I'm using df underscore read emp dot select dot select. Right? I want to create only ID name. Only ID name. We can create here also because why should I create select? But why should I restrict? Let me create maybe if this data frame, right? Maybe other logics maybe use all the columns, right? Then they will refer these things, right? If other logic they need only these two columns, right? Then they will refer this data frame, right? Now two data frames are created, right? See, this data frame contains ID name, right? This data frame contains ID name. The first data frame contains ID name, salary, ID name, salary, ID name. ID name salary, ID name. Right? The select methodology, right? The select methodology, you can select the specific columns, which columns you want to include in your calculations. Include in your calculations. Include in your calculations. Clear at any doubts?
This dot duplicates function based on the total row, but if I want to ID only specific ID
Then
specific column.
another transformation. That is called filter rate.
I
That is
mean, if
called, for example,
same ID 1 1.
I'm giving these things. Select ID comma. What it will do? It will display only ID name data, right?
Yes.
What is the requirement?
For example, employee number
Not
one,
one.
1A.
ID equal to one.
Yes.
Okay.
Um,
Then what you will do in Oracle? You include the very class, right?
yes.
Right now, the same thing right here. You have to include some transformation. ID equal to one means it will display only ID name, salary data. Right? You have to do some transformation.
No, same ID. I want to display max salary.
Same ID. I did not get you.
For example,
Means
1A,
yes, you want to execute max of salary.
max of salary from EMP where ID equal to 1. Yes.
So this is a transformation, right? Aggregations, right? We should involve that aggregations functions on the data frame.
I mean, for every ID, I want max salary. I mean, if it is duplicates, we
Right.
can.
Means then say group by, right?
Yes, group by. I mean, can we achieve this
Yeah, we
using?
can. With all the things are possible. This is with the help of the group by functions. We have some aggregation functions. With the
Okay,
help of that aggregation functions.
every class for data from database we can apply.
Right. Yes, 90 percentages are available. Even we can have the more options also than database.
Oh, okay.
Each and everything is possible. Convert to your requirement. Simple. Forget about data frame. Now you know this query, right? You know this query. But wait,
Okay.
where is our Spark SQL? I think we will refresh it, right? Percentage SQL to the table. right?
Okay, understood. Got it.
For example, just timing, for example, you don't have knowledge on the data frame, just assume, but you know how to create the data frames. Maybe you did some Google, you get some syntax to create the data frame. So what is your next, right? So why should I execute again the Google, right? Why should I search again into the Google? Let me create the table. Let me create the table. Now you're good at SQL. You can happily execute your SQL queries, right? Right? You can execute your SQL queries. This is also possible. This is also possible. Otherwise, the same equivalent we can execute from the data frame also. The same equivalent your wish. So there is no restriction in the real time. Either if you're good at SQL, people will prefer that SQL. If they're good at data from they're from Spark background, Hadoop background, right? Not from the database background, people will prefer the data frame syntaxes. If you're from the database background, people will use the Spark SQL. Depends on their convenient. Depends on their convenient.
Okay.
Depends on their convenient. Clear, right?
And these records are distributed into different nodes, huh?
Correct. Based on your partitions, right?
Okay, so if we do group by or any analytical functions,
Yeah,
uh,
it will do the shuffling, right?
performance will
Right. I mean, it will do the shuffling. Performance anyway, that Spark will taken care, right? Spark will taken care. Depends on your number of partitions, right? For example, see data frame dot, right? Get num partition. We'll see whether do we have that option. There is no option, right? Dot get,
yes,
right? But this option is available in the RDD, right?
yes,
Right. Dot R. We have that RDD, right?
yes, yes.
RDD dot tab. Get.
Okay,
Now you have the get num partition. This is also interview question. All right. Last time we had discussed, right?
yes, yes.
Means your
Okay,
data frame you're converting into
RDD,
RDD. From RDD, you're getting the number of partitions. Mean indirectly, your data frame is using how many partitions?
four partitions.
Four partitions. These are also interview questions. How to get the partition value from the data frame?
I
Because
mean
we don't
that
have
data
that.
frame, the data frame is converted into RDD. Yeah? So
Correct.
I mean
Means
basically,
physically it's not complete data is not correct. Still you have the data, right? Only you want to get the number of partitions only you're converting still. Not completely moving, right?
mhm.
Right? Not completely moving, right? Still you have the data, right? Only to get the your partitions, right?
Okay.
Right? Still you're able to see the data, right?
Yes, yes.
This is you. You want to know the partition value, right? You want to know the partition value from the data frame. But how can you? So this is a methodology. Converting high to low, right? Indirectly you're doing, right?
Yes.
2.x to you're converting into the 1.x. Means just comparison I'm talking about means high to your low converting you're getting, because unfortunately we don't have this option, because if you want to see the partitions, the Spark should convert into that RDD, then only it is possible to see the partition. This is 100% interview question. I want to see the number of partitions from the data frame. That answer, there is no straightforward direct answer. There is no way to get the partition from the data frame. You have to convert into RDD, then only you can see the partitions.
But in the background, the data frame also that RDDs, right?
Right. Yes, backend it will convert into the low level API. The Spark will take care of, not by you. The
Okay.
logical execution plan, physical execution plan, the DAG, right? The
Yes.
Spark will convert, not by you. Your responsibility, you have to create that RD. You have to create the data frame. The backend, while executing, it will convert into their own native format.
Okay.
Any doubt the select function, drop duplicates.
So dot duplicate function when we will only use when we are building that this thing, right, sir? When we are reading the record only, right, sir?
Correct. Depends on your requirement. Yes, in your requirement, you're reading the data from multiple files, but you realized you're extract some duplicates. Maybe same data, row level data is available in the multiple files, maybe the single files. Now you don't want to end up with any duplicates into your process. The easiest way we will use the drop duplicate set.
Okay, sir.
This depends on your record. This is not mandatory include. Depends. Now you want to disable the duplicate records, right, into your data frame. You can use the drop duplicates. Otherwise, no. Let me create all the records. Right. Let me create one more unique data frame. There I want to use the drop duplicates. Means you can use your wish. Depends on your requirement. Depends on your requirement. Any doubts? Okay. Then we'll write the data, right? So we'll talk about the detailed transformation in the next class. Then we'll talk about how to write the data. Then we'll talk about one use case. Okay. I want to write the data. Last time in the RDD, we are using the same text file option, right? There is a save text file option, right? But how can I write this data frame? How can I write this data frame? We'll use the write operation. To read the to create the data frame, we are using the spark.read, right? Spark.read. If you want to write the data, right? If you want to write the data, right? If you want to write the data, right? You have to use the write methodology. Right, save dot, sorry, CSV module, right? Format CSV, right? Dot save option. Load means importing the data. Save means you're writing the data. You're writing the data. Right. File store slash tables slash. I want to write the data into my folder. Right. I want to write the data into my folder. Right. Let me write the data into this target system. Right. Now you have copied this data frame, means your final output data you have saved into this file target system, your database file system. Let me go and open DBFS, that file store, tables, what's the directory?
File target.
File target, right? See how many files were created? Four types of files, right? Overall count is 7, but 4 types of files were created. Underscore success, underscore committed, underscore started, then the data files. Now the data files were 4 files, right? Part hyphen some value, part hyphen some value, part hyphen some value, part hyphen. Why you are able to see the 4 files? Because your data frame is having how many partitions? 4 partitions, right? 4 partitions. Right? Depends on your data frame. Depends on your data frames, the number of partitions. If the number of partitions are 10, the 10 part files will be created. If it is 4, means 4 files will be created. That is it. Spark will taken care, right? The default, the Spark backend, it will be taken care. But you're able to see underscore success, underscore committed, underscore started. Correct. Let me execute the same command one more time. Correct. Let me execute the same command one more time. What is the error message? File target already exists, right? File target already exists. file target already exists. But but in the especially in the real time, target always available, right? Target always available. But how can I handle it? How can I handle? Let me use mode. Let me use that mode append. Let me go and check, right? Let me go and check my data. Now how many files you're able to see? 8 part files, right? 8 part files. 2 underscore started, 2 underscore committed, 1 underscore success. 1 underscore success. Why you're able to see 8 part files? The maybe the first 4 part files are belongs to the first writing. The second 4 part files are belongs to the second write, because you're using the which option? Append option. You're using that append option. You're using append option. Let me see the content of here underscore committed display dbutils dot fs dot ls. All right, let me see the size. Let me see the size. Let me arrange first. But see, your underscore success is the size is 0. Your underscore started 0. Your underscore started 0 means underscore success underscore started. It's not having that any information, but committed is having some information. Right? Committed is having some information. Let me see the data from that committed. What kind of information? Right. dbutils dbutils dot fs dot head option, right? dbutils dot. Let me execute. But what kind of information? See, it is added, right? It is added, removed, no files, right? It contains what kind of part files you're adding to your target system. I mean, this underscore committed contains your part file names information plus which files you were removed during your process. Which files you were removed during your process. But do you think this if information will help out? No use, right? This contains right what kind of part files are available, right? Part file names are available, whether it is added or whether it is removed, whether it is added or whether it is removed. Those file names informations are available. File names informations are available. Clear, right? Right. For example, no, I don't want to do that append. I don't want to do that append. I want to do the overwrite. But truncate and load, right? Truncate and load. But let me execute. How many part files? Only 4, right? Right. How many part files? Only the 4 part files you're able to see, right? Only the 4 part files you're able to see, because you're using which option? Overwrite option. You're using that overwrite operation. The overwrite option, that mode overwrite mode, it will do the truncate and load, right? Existing files it will delete and it will do the new files creations. Append means it will add the data. If you're not using dot mode option, right? If you're trying to load the data to the same target system, it will fail. Because path already exists, right? What kind of operations you want to perform? So this is a entry question. For example, if I'm not using dot mode append or dot mode overwrite, if you're executing the same operations next time, definitely it will fail because already target is available. All right. If you don't want to include dot mode option, means your target path always should create with a new folder. Then only it is possible. Means like file target inside year, month, day information. You're 100% sure. Year definition the same day it will not execute. The same path it will not create two times. Then no need to use the dot mode. You're 100% sure each and every execution I'm creating into the new folder. Then that is called append. Then no need to use the dot mode append. But the same target path you're executing multiple times, then you either you have to use append or overwrite. If you're using the overwrite, that existing data will be deleted right from the data frame. The data will be added to the your target system. If you're using that append mode, right, it will create the new additional files. Any doubts? Clear that when should I use append, when should I use that overwrite, when should I use exclude the dot mode option? Kiran, any doubts?
No, bro. Clear.
Okay, super. Suresh, we can discuss, right, Suresh? Is it too late? Sorry. Yeah, sure, sure. Okay, no problem. Let me share this file. But this is clear, right? Operations.
Sir, you sent that file and that PPT also, sir.
Sure, sure. I will share. Yeah.
Sir, one small doubt, sir. Sorry, I lost in between. That mode you were saying, right, sir?
Yeah.
Append and override. So
Mhm.
append is when we will only go when we know that we wanted to have the same consistent number of files. Correct, sir?
Not consistent number of files. Right? Just for for okay. Forget about the consistency. Okay.
Mm,
Okay. Your target location. Your target location. Always it is constant or not. Like
correct.
for example, /mnt ADLS.
Yes,
Okay.
sir.
Target path. Always I want to write the data into this location. All this is my location is constant.
Yes, sir.
All right. So the your notebook every day you will execute, right?
Yes, sir.
Every day execute means every day from your DF final, right? For example, this is your calculated DF underscore final dot write operations, right?
Yes, sir.
Right, sir. Write dot, for example, save option, right? Save option. Maybe this is your variable. Just assume this is your variable. Okay. This
Yes.
variable contain this location. Okay. Very first execution, the process it will not fail, right? Because this path is not available, right? Because this
Correct, sir.
target path you have created in the runtime. You have
Yes.
created in the runtime. The first time it will create. But what about the next day? The same
Next day, the
path, right?
path will already exist, sir.
It will fail, right?
Correct.
But what is that alternative way? Okay, you're 100% sure your target always constant. But what kind of operations you want to insert into your target side, right?
Okay.
Yes, I want to use append operation. If if the target is already available, go and insert the new append file, right? Right.
Append file means it will create another file, another
Another
partition file.
for example, maybe this data frame contains four partitions. Another four part files will be created under this target location.
Okay, sir. Next day when we run it.
Correct. If you're
Okay.
using, right, if you're using that overwrite operations, what it will do? It will delete that existing files.
It will delete and write with the new files.
Correct. With new part files. But at any cost, it will create only four part files. Here,
Okay,
just
sir.
assume these are four partition. If it is one partition, only one file to create.
Okay, sir. So we
So
are using mode in order to ensure that there is no job failure when we run the next time because the target location path is always consistent. And when the target is already created, the job will fail, right, sir? That is why we are using
correct.
modes.
Depends on the requirement, right, sir?
Define something.
Your
Okay.
target location, always each and every execution, you're creating it as a new folder, then mode will not help out, right? No use, right?
Correct, sir.
But here also you're having that issue. your target location, day wise you're creating the folder, or minute or second wise you're creating the folder. Day wise you're creating the folder. Within the day, if you're executing your process more than once, this process will fail, right?
Correct, sir.
Then here day wise folder you're creating, I don't want to encounter any issues, then go and create dot mode overwrite operation, because in the within the day I don't want to end up with duplicate multiple files, right? Use the dot mode overwrite or dot mode append, depends on your requirement.
Yes, sir.
It depends on your calculations, right? Each and every execution you're extracting delta data from your source, right? Then always go with dot mode append with target location. Now always I'm doing that calculations, full extractions, right? Full extractions, then go with overwrite operations. Delta extractions, then think about either append or overwrite. If it is append means, then you may end up with duplicates. But append means you will lose that existing data. Then we should tweak our code, right? Then we should change our logic, right? We should change our logic.
Okay, sir.
Clear, right?
Clear, sir. Clear.
When should I use that mode append? When should I use that mode override? When should I use off my mode option? Right? 3 use cases. I think you want to finish the class, right, Uday? You don't want to extend our discussion or conversation, right?
Uday has become weak from past 2 days, sir. 2 weeks, sir.
Sorry,
He's not talking
sorry.
at all. Uday.
Maybe he's doing some Maunavratam.
Maunavatam you're doing, Uday?
Yeah. He's a bachelor, right? He wants to get married.
So you're planning for marriage, huh?
Yeah, that's why he's doing.
No, right? Okay. Because 2 weeks I'm not seeing you talking only, na? That is why I said, sir. Hometown means you will not talk more, huh? Okay. Okay.
So that is the best answer. Right? You should say a little bit busy. If the data connection again, he will ask, right? Data connection, you don't want. Okay, yeah. Please, I mean, execute. I mean, please import the DataFrame underscore one dot Python file. Right. Please execute once. Note down all the what kind of functions we discuss in the DataFrame. Right. Please by heart. Every day we'll execute
Yes,
only
sir.
these transformations. Every day, read, write, display, show, print schema definitions. Okay.
Yes. Yes. Sure.
Any other doubts?
Sumant bro, last week we used one colesic function, right?
Yeah, that
Like
we'll discuss in
it will
detail. Yeah. The
okay.
coalesce
Like
means downgrade your partitions.
yeah. Like if you want to divide 2-3 partitions, we can divide by using that or only one partition.
Your wish, right? Coalesce not only one. You can number, right? You can give 3, 2 also. Your wish.
Okay. Like if suppose we have 10 partitions, we can take it as 2,
Yes.
right? Like 5
Your
5
wish 5.
5 5.
That is the number, right? That is the number.
Yeah. Okay.
That is the number. Coalesce of your number.
Okay, got it.
Once coalesce is done, sir, coalesce function is done on the number of files. If we wanted to again bring it back out to 5, 6 files, can we do it, sir?
Repartition. Dot repartition.
Dot repartition. Okay.
We can increase with the help of the dot repartition. Decrease coalesce.
Okay, sir. Tomorrow we are connecting, sir.
Yeah, we will. Tomorrow we'll connect 7 o'clock only. Okay.
Okay, sir.
Okay. Thank you.
Thanks,
Thank you,
everyone.
sir. Thank you, sir. Bye.
Bye. Bye.